This is the Chem 1 lecture for acid and base theories. And so this is a continuation of our acid-base properties lesson. So we're using the same notes. So we've been in Unit 16, letter A. And so try to find that page if you are taking notes with our provided notes. It's like midway down a sheet of paper and you're looking for where it says theories. Our goals for today are to understand there are two different theories for how scientists have described acids and bases. And so we want you to know both of them. So the first is that you will be able at the end of this lesson to be able to describe an Arrhenius acid or base. And then you will also be able to identify Bronsted-Lowry acids and bases as well as conjugate acids and bases. So these are going to be the two topics we're covering in today's lesson. Okay, this next part is we're going to be talking about theories of acids and bases, and there's two main theories that we're going to be holding you responsible for. So the first theory is called Arrhenius's theory, and he basically said that acids are compounds that when placed in water, they're going to dissociate and produce hydrogen ions. And bases are going to be compounds when placed in water are going to have hydroxide ions. So based on Arrhenius's theory, if I gave you a beaker that has lots and lots of hydrogen ions, it would be considered acidic. Or if I gave you a beaker that had a high number of hydroxide ions, it would be considered basic. So kind of what we just mentioned on the other side, if we put hydrochloric acid in water, which is a strong acid, we would see dissociation and there would be a lot of hydrogen ions. Same thing with sodium hydroxide. It would dissociate and split up, and we would see a high number of hydroxide ions, classifying this as a basic solution. So the only thing that didn't work for Arrhenius's theory is that ammonia, NH3, has properties of a base. Yet it doesn't fit the category of there's no hydroxides. And so this theory needed to be broadened, that Arrhenius's was pretty narrow. Bases have to end in OH, acids have to start with an H. And so a different guy, or two different scientists brought in a broadening theory of what acids and bases and how they behave. So those two scientists were Bronsted and Lowry, and this was their theory. They said acids they don't have to start with an H, but it's any compound that can donate a hydrogen in a reaction. And that bases would be defined as any substance that can accept a hydrogen in a reaction. So it's no longer kind of what it starts with and ends with, but can it donate a hydrogen or can it accept a hydrogen? You can also interchangeably say proton, and they're also just referring to hydrogen. I also have a bad acronym, and then Bronsted starts with the B. Here's a recap. Bases accept, acids donate. Because it can be easy to flip those. So here's a little mnemonic that can maybe help you. So Bronsted-Lowry had a bad acronym. Okay, so let's look at a chemical reaction and see if we can classify the acid and the base. So something I do is, here is HCl before the reaction, and then I look for its similar thing after the reaction. So here's our arrow for before and after. So HCl and Cl ion, and then H2O and H3O plus. And then I just look at what happened before and after. Well, before the reaction, hydrochloric acid had hydrogen, and then it's gone. So that means HCl must have donated in the reaction, and H2O absorbed it, and that's why it's now H3O plus. So based on Bronsted-Lowry's definition, acids are the one that donate the hydrogen. Well, hydrochloric acid donated it, so we're going to classify that as the Bronsted-Lowry acid, therefore making H2O the Bronsted-Lowry base. Notice we're classifying just the reactant side. We're going to handle the product side in a little bit. Okay, let's try another example. So first thing I do is, if the chemical reaction, I like to pair up like terms. So I see this ion before, and then after this reaction, I see that it has gained a hydrogen. So that indicates to me that H2O must have donated the hydrogen. And we know from our BAD acronym that bases accept and acids donate the hydrogen. So if water donated, that makes water the acid, and that makes this acetate ion the base. So if you guys noticed, water in our last two examples, one time it was an acid, one time it was a base. And so a substance that can act like an acid or a base is classified to be amphoteric. I kind of think of the word ambidextrous, like you can use both your hands. Amphoteric, you can act like an acid or a base. Okay, let's talk about now the product side. So we know on the reactant side, there's an acid and a base. And now we're going to talk about what's happening on the product side. So here it just says species that differ by the presence of one hydrogen ion. So a conjugate acid is going to be the particle that formed when the base gains the proton. So when the base accepts, and kind of the way you think about it is if the reaction reversed itself, it could like redonate that hydrogen back. A conjugate base is the particle that lost the hydrogen. So what is this? So this acid donates, it becomes a conjugate base on the product side. So once again, when an acid loses the proton, it then becomes a conjugate base because it could accept the hydrogen back if the reaction reversed itself. And then likewise, the base that accepts the hydrogen on the reaction side becomes the conjugate acid because it could then donate it once again if the reaction reversed itself. So now let's look at this chemical reaction and label everything, the acid and the base as well as its conjugates. So like we did before, I would still pair up like things, one on each side. And then I typically label the reactants first. So I look at NH3 and I track it. So before the reaction, it had 3 hydrogens. After it has 4. That means it must have accepted during the reaction. So we know acids donate. That makes water the acid. And bases accept. So NH3 is the base. H2O is the acid. Well, we know that NH3, it becomes opposite. So if it was a base here and now it accepts it, now NH4 is the conjugate acid. And then H2O, if it was an acid on this side, it becomes opposite on the other. It's a conjugate base. Because if this reaction were to go backwards, it would just redonate. So this acting like an acid, this acting like a base. Another way to think about this is like your pair, the before and after, should always have one of each. So like you shouldn't have base and conjugate base. You should have an acid and a base. One of them has to be a conjugate because it's on the product side. So here you have a base and a conjugate acid. Here you have an acid and a conjugate base. And then a third way, I'm a little hesitant to share it because it's kind of a shortcut, but I want you to make sure you understand what's going on, is that in the pairing, the acid or conjugate acid, whatever the A is going to be, will always have more hydrogens than the other one. So this conjugate acid has more hydrogens here, and then H2O and OH, the acid always has more hydrogens in the pair. So let's do another practice problem identifying all 4 components. So the first thing is to match up like things. And so kind of the technical one is figure out who's donated. So HCO3, CO3, they've lost a hydrogen. So that's our donate. That's our acid. Therefore, H2O must be the base. Label that. And then we know in a pair, it's going to be the opposite on the other side. So if this was the acid, now this is the conjugate base. And if this was water was a base on this side of the reaction, arrow being the split, then it would be a conjugate acid. And just to confirm, the conjugate acid has more hydrogens than the base. This acid has more hydrogens than the base. And then lastly, kind of everything goes opposite when you cross over. So for example, hydrochloric acid is a strong acid that can donate, and it will become a base on the other side, and it will also become weak. So it was strong acid over here, weak base on the opposite side. So the stronger the acid or the base, the weaker its conjugate is going to be. Okay, we have 2 more problems left in the whole lesson. It says, write a balanced equation for the reaction that occurs with the cyanide ion and it accepts a proton from water. Okay, so we have a cyanide ion. It's going to react with water. They're saying that that ion is going to accept the hydrogen from the water, creating HCN. And then if water loses one, it's going to become a hydroxide ion. Okay, and then the question is the cyanide ion a Bronsted acid or base? So I'm going to match up like things. So if cyanide accepted, that would make it a base, and water would be a Bronsted-Lowry acid. So just to repeat it one more time, if this helps, Bronsted-Lowry had a bad acronym. Bases accept, acids donate. And so because cyanide accepted, that classifies it as a base. Okay, last example, write a balanced equation for the reaction that occurs when phosphoric acid donates a proton to water. So I'm just going to try and draw this out. So it's going to get that. H2O is going to accept and form H3O plus. And then this one will be down one hydrogen, forming a negative charge. Is the dihydrogen phosphate ion a acid or a base? Okay, so dihydrogen phosphate ion, they're asking us what that is. So we know that the phosphoric acid donated the hydrogen, that accepted, and so this would be opposite, and if it's an acid on this side, it's a conjugate base on the opposite side. So the dihydrogen phosphate ion would be classified as a conjugate base. Okay, that concludes our lesson. I know that was a lot of information, and so please, please, please work on your practice so you know your properties, remember how to name things and your theories, keep them straight. Arrhenius versus Bronsted-Lowry. Thanks for listening. Hope you have a great day. Now that we've completed the lesson, it's time to practice, and so you're going to flip the page because we've already practiced numbers 1 through 15. And now you're looking for questions 16 through 23. So please take time to practice the 2 different theories and being able to identify, and then we will see you next time. Also remember that these homework answers are posted in Google Classroom under Unit 16, the filled in notes and practice key. So then you can try to self-assess, check yourself even before we see each other next class period, so then we can go over some specific questions you have over the lesson.